All right, so in 4.6 today, we're going to talk about applying the exponent laws. So this is basically a summary of what we've been learning the entire chapter. So not a lot new here at all, but instead what this is we're going to formalize now all of these little rules we've been stumbling across, okay? So these are the laws we're going to study. Product of powers, okay? So if you have a power, a to the m, and you multiply by another power with the same base, there's a certain way you do that. There's a certain rule there. Quotient of power, so quotient means dividing. Power of a power, so a power raised to another exponent there. Power of a product, and power of a quotient. So let's take each one of these separately, and we'll take a look at these. So the first one, product of powers. Okay. So when you have a product of a power, if you have the same base here, if this base is the same, if you have different bases, this doesn't apply. It only applies if you have the same base. That's why the A is written twice there, you see? So a power with the same base, then what you can do is you simply take a look at the exponents and you add them. Okay, you don't multiply the exponents, you're multiplying the terms, but you add the exponents, okay? So you add exponents here. So let's do a couple examples then. So an example would be if we had x to the 5 times x to the 6, all right? So we are multiplying these powers, so a product means multiplying. Multiplying, that's what product means. And what we do is we retain the base, just like over here, we keep the same base, and I add the exponents. So that's x to the 11 is the answer there. It's not x to the 30. We do not multiply the exponents. We add the exponents, okay? A little more difficult if we have ab squared, let's say, times ab cubed, okay? Now we'll get to this, but this is the same sort of idea. You look at the within a term, the variable, that's the same in both, okay? You add their exponents. And if there's no exponent on A, what exponent is that really?
1.
Yeah, that's very important. We have to remember that's a 1. So we're left with A to the power of 2, and then times, what's B squared times B cubed? That is B to the 5, right? Not 6. We don't multiply, we add. So that's what we get when you have more than one variable represented, okay? So that's kind of a second level question there already, but you have the idea. Now, consequently, so this actually works with any kind of number as well. So if we have 2 cubed times 2 squared, guess what? I know that this is 8, and I know that this is 4, so this should be 32. But if we use our exponent laws, this should be 2 to the power of what? 5, which is exactly 32. So it works with regular numbers, it works with variables. It's a law, okay? Product of powers. Everybody feeling okay with that?
Yep.
Yes? All right. Okay, let's take a look at quotient of powers. Now, obviously, quotient is dividing, product is multiplying, quotient is dividing. Let me just make some more space here. So when we divide powers, you notice the rule is very similar for division as it is for multiplication, but instead of adding exponents, if you have common base, you subtract exponents. Okay, so x to the 5 divided by x to the 2 becomes, retain that like base, 5 minus 2, or x cubed. Can someone grab that door, please? That next class is really loud, or somebody's really loud out there. This becomes x cubed. Okay, does that make sense? Now, let me show you how this looks when I prime factorize things. Okay, look at this is 5 x's multiplied together divided by 2 x's multiplied together. Okay, if I split them all up into prime factors there, guess what? I can take 2 from the top and 2 from the bottom, and I divide those out. They divide out to be 1. So I'm left with x times x times x. Isn't that cool? So that's the idea. Now, what happens if we have x to the 7 divided by x to the 10? Well, that's like 7 x's, 4, 5, 6, 7, divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. And 7 on top and 7 on the bottom will divide out. That's to be 1. And I'm left with 3 on the bottom. The exponent laws say that this should be x to the 7 minus 10, which is x to the negative 3, which is actually 1 over x cubed. And do you see that that's exactly what I have over here? I have 1 over x cubed. That's what's left over. So your exponent laws are going to work whether the number on top is bigger or smaller or whatever. Okay? Questions? Got that? Okay, 5 out of 5? Yeah? All right. A power of a power. Okay. So, again, these are exponent laws or rules or shortcuts, okay? And I will show you kind of the long way to convince you that this can be a rule you can be applying to any situation. But when we have a power of a power, there is a bit of a shortcut. Let me just show you the long way first. Let's say I had a squared squared. Okay. Well, that actually means a squared times a squared, doesn't it? It's times itself 2 times. Now, if I use my product, my product rule from the beginning there, then this would be a to the 2 plus 2, or a to the 4. Okay. Well, according to this power of a power rule, I can go simply straight to a to the 2 times 2, which is a to the 4. Okay? I can simply multiply. A power raised to a power, you multiply. Okay? So 2 plus 2 and 2 times 2 are the same number, so maybe that was a bad example to pick out of the air. But let's do y to the 3, okay, squared. Okay? That's y times y times y times y times y times y. That's y to the power of 1, 2, 3, 4, 5, 6. My little rule says that I can multiply the powers. That's y to the 3 times 2. What's 3 times 2? 6. Everybody see that? So a power raised to a power, multiply. A product of powers, you add exponents. A quotient of powers, subtract exponents. Okay. All right. Power of a product. Power of a product. Okay, so this is the power of a product. If we have, and again, we're getting into we sort of did this the last section, really. I kind of sort of talked about this a little bit, both these. But if you have something like, well, let's just use AB squared. Okay? So really, this can be written as AB times AB, or A times B times B, or A squared times B squared. All right? That's the way you can kind of imagine that. That's the way you can sort of write that out in its long, in a long drawn out way. So notice what's happened here. For each factor, so this is an A times B. So whenever they're multiplied in the brackets, because it's a product, you see, AB is a product, and you have a power for a product, that means you can basically split, like this exponent can go to each factor that's in there. So you can go straight to A squared, B squared. That's the shortcut, you see, for what we just showed you there. All right. If it's negative exponent, no problem. Still separates. If there's more than one, okay? If there's more than one variable, okay? And if there's a number, okay? Watch this. Watch this. Are you ready for this one? 3 x squared y cubed. Oh my goodness. Okay. Because 3 is a factor here, and x squared is a factor, and y is a factor, what this means is that this exponent applies separately to each one. Not the case if they're added or subtracted, only if they're multiplied. So that means I can write 3 cubed times x to the 2 times 3 times y cubed. Or the answer here is 27 x to the 6 y cubed. That's my answer. And if you write this out, watch this, this also means this. Which, if you were to do this, you would go 3 times 3 times 3. Oh, that's 3 cubed, 27. And you would go x squared times x squared times x squared. Oh, that's x squared cubed. Oh, that's x to the 6. And you would go y times y times y, or y cubed. Okay? So these are just shortcut rules for stuff that, this is nothing spooky about this. Okay? All right. Okay, so now what we're going to look at is power of a quotient. Power of a quotient. So a quotient, remember, is a division, right? So if we're dividing something there, if we take that quotient or that fraction or that ratio to a power, and again, we touched on this last day, but just like the power distributes to factors in a product, powers also distribute to factors in a quotient. All right? So notice that if you have a fraction, like let's say 1 over 3 to the power of 2, okay? You can rewrite that as 1 squared over 3 squared. 1 over 9. All right? Does that make sense? Well, yeah, it does actually, because 1/3 squared is also like this, 1/3 times 1/3. So we would multiply top times top and bottom times bottom. That's 1 over 9. Okay. Now let's just let's up the stakes a little bit here. What if we had something like 5a squared over b, and we took that to the power of 3? Whoa, whoa. Okay. So a couple ways you could look at that. This is 5a squared cubed divided by b cubed. See how it applies to the top and to the bottom separately. Further, this we know works like this. This is 5 cubed a to the 2 times 3 over b cubed. Finally, 5 cubed is what? 5 times 5 is 25. 25 times 5 is 125. Good. A to the 6 over b cubed. 125. See? Putting these two together, this 3, oops, let me change colors there for you. Come on now. This 3 applies to the 5 and to the a squared separately, and it applies to each factor in the denominator as well. So that's kind of putting both rules together. Whew. Is that tough? You got that? Okay. I'm going to do some more examples that maybe seem a little bit strange to you, but let me just get a couple of those copied up. All right, so a couple more examples here. We have a squared b over ab cubed. And again, if you, for 2 and 3 as an exponent, 2 is squared, 3 is cubed. If you don't remember that, you can say a to the power of 2. Don't say a2. Just don't say a2, okay? Bugs me. Plus a2 is like, what do you mean a2? Do you mean like a sub 2? Do you mean like the second a? No, you mean a squared. So say a squared or a to the power of 2. Don't say a2, okay? Just because I hear that lots. I've heard that for years. So please don't say that, okay? It's to the power of if it's an exponent. Okay, so simplify. All right, so it appears that we have a quotient here, right? So let's take a look at the first one. And if we were to divide this out, what we would do is focus on the factors in the top, which is I have a and I have b, and on the bottom, and I would focus on the common factors. You see a squared here, and this is a to the power of 1 here. Very good. Oh. Crash. Y. coming back. It's coming back. Okay. So this is b to the power of 1. This is a to the power of 1. Excuse me. So what we do here is we focus on the a parts right here, and we focus separately on the b factors here. So this is going to be a to the 2 minus 1, because that's the quotient rule. And then times b to the, watch this, 1 minus 3. Because I subtract exponents. The top one minus the bottom one. So this is a to the 1. This is b to the negative 2. Okay? So if I want positive exponents in my final answer, which generally is typically, that's what simplified is, then I need to fix this one, right? So I'm going to write this as a, and we typically do not write the 1 as an exponent, so don't write the 1 as an exponent at the end, please. And this is b squared. Okay? And you can see that, I think, right? Watch this. I'm separating all of the factors here, right? And so if I divide off common factors, that's gone, and that's gone. So I'm left with 1a on the top, and I'm left with 2 b's on the bottom, so that's a over b squared. See that? Good? But we're using our rules, subtracting exponents. Okay. All right, this one. 2 parts to this one. This one is a bit of a multi-level problem here. So please don't do this. Don't say, oh, 2 minus 3, I'm just going to do that. No, 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 no. When you have a quotient like this, okay, and when you think about order of operations, this division symbol here is a big wall. It's a wall. You have to simplify, and you have to clean up this top and bottom separately first, okay? So it's kind of like a wall. Before you simplify on the top separately, don't start to cross up and down, okay? So what that means is this. This one should be, you guys okay? You have a question? Something you want to ask about?
Yeah.
Yes.
For the one before, why
Yep.
did the b to the negative 2 just become positive?
Why did the b to the negative 2 just become positive 2 here?
Yeah.
Okay. So remember, when you have a negative exponent from yesterday, the lesson was if you have a negative exponent, that takes that power, either if it's in the numerator, it takes it down to the denominator, and the exponent becomes positive.
Yeah.
Or if it's in the denominator, it goes to the numerator, and the exponent becomes positive. So as I mentioned here, simplifying, I want to simplify my final answer to have all positive exponents only.
Yeah.
So this is not a final answer.
Yeah.
Okay, all right. So how do I fix this negative 2, this negative exponent? This power, b to the negative 2, that negative takes this b to the bottom. And the a stays up in the numerator because it's positive. The b goes to the denominator and becomes positive.
Wasn't it already in the denominator?
The b's are in the denominator here. Yes, what this means is that they're in the denominator. But when you do your exponent rules like this,
Yeah.
you see, 1 minus 3. So this is a b to the negative 2 in the numerator.
Oh, okay.
It's b to the negative 2 in the numerator.
Yeah.
So b to the negative 2 equals 1 over b to the positive 2.
Yeah.
Yeah. So when you do this subtraction, okay, which I think maybe is your point. I don't know if that's what you're meaning to ask, but it's a good question. So when you do this subtraction rule for the quotient like that,
Yeah.
whatever the answer is, it's always in the numerator, always up top. And then you go from there and you fix it to move it around if you need to. Yeah,
Makes sense.
yeah. So any subtraction always is in the numerator,
Yeah.
and then you can go from there. And we'll get that again here in this one probably. Okay, so back to the second one. What we're going to do is we're going to apply this power to a power. We're going to do the power to the power thing first. So this is actually x to the 2 times 2 is x to the 4. Then we've got y to the 3 times 2, y to the 6. On the bottom, we've got x to the 3, because it's 1 times 3, x to the 3. And this one is y to the 2 times 3, so that's y to the 6. And we have z to the power of 3. Z to the power of 3. Okay, so we're doing the power to the power thing separately in the numerator and denominator. Good with that?
Yeah.
That's how you do that first. Now we look at dividing and see if there's any simplifying we can do. And of course, when we see a factor of x and a factor of x on the top and bottom, I know I can simplify those. I can use my quotient rule. When I see y as a factor on top and y as a factor on the bottom, I can use my quotient rule. Now the z down here doesn't have a z up on the top, so guess what? That z cubed is going to stay as it is in the denominator as just z cubed. It's not being divided off with anything. So it looks kind of like this. I'll go sideways here for room. So this is x to the 4 minus 3. 4 minus 3. This is times y to the 6 minus 6. 6 minus 6. Z, now, z, okay, what? Well, if there's nothing there, technically, that's a z to the power of 0. So if you want to understand this in terms of your exponent rules, that's z to the 0 minus 3. Okay? All right? What that means is x to the 1, y to the 0, and we'll talk about this in a second, z to the negative 3. Or this is x on top, z cubed on the bottom, and whenever you have a variable or a number or anything really to the power of 0, it always equals 1. So the y to the 0 is gone. Just like z to the 0 wasn't there, right? That was gone. So y to the 0 means it's just 1. So you might want to write this down. I'll highlight my answers here. Answer and answer. So you might want to write this down on the edge here on the side of the notes here. Any base to the power of 0 equals 1. Except when the base itself is 0, that's the only restriction. But any base to the power of 0, the whole power equals 1. Everything equals 1. And I'll explain that just real briefly here if you want an explanation as to why that is. Because here's why this little rule is the way it is. Because if you have anything like a cubed and you divide it by itself, that always equals 1, right? You know what else equals 1? A b to the 4th divided by the same thing, b to the 4th. That also equals 1. Any quantity divided by itself equals 1. And of course, if we use our exponent laws here, this is a to the 3 minus 3. So that has to equal 1. This is a to the 1 minus 1 times b to the 4 minus 4. So this is a to the 0, and this is a to the 0, b to the 0. So guess what? That has to equal 1. We know that from before. So any base to the power of 0 equals 1. All right? Okay, any questions about the examples we've done so far? Any of this, all this making sense? All these rules making sense?
Yeah.
You're just gonna have to take some time to study these rules and to memorize them. Okay? You can do it though. All right, let's do some homework questions then. Let me see, some questions from your homework. Okay, let's do number 8 here. Let's take a look at number 8. All right. So simplify. Okay, simplify. I believe that simplifying is always going to mean a positive exponents in the end, I believe. Yeah, it's going to mean positive exponents, okay? So this is a squared over b what? Yeah, squared. Positive exponents, got rid of our brackets. So getting rid of brackets is another way to know that you've simplified. Brackets gone. Okay, b, so this is going to be n to the 2 times 3 and m to the 3. So this is going to be n to the power of 6 over m cubed. No brackets, positive exponents, done. Now these are different letters, so we can't subtract 6 minus 3. Okay, don't do that. Because they're different bases. These exponent laws only work with the same bases too, remember that, okay? Because I've had students do that. It's like, oh yeah, no problem, n m to the 3, 6 minus 3. No, that doesn't work. Okay, only if they're the same bases can you do that. All right, let's go to C then. Oh, it's getting tough now. Look at all this. So this is going to be C to the 2 times negative 4. What's 2 times negative 4? It's negative 8. On the bottom, this is going to be d to the power of 2 times negative 4 as well. So d to the negative 8. Okay. Now I've got negative exponents in both the top and the bottom. So who has an idea of how I might make this a positive exponent now? Anybody? Yep. Okay, so the c to the negative 8 has to go to the bottom, and the d to the negative 8 has to go to the top. So yeah, it means the reciprocal. So it's d to the positive 8 and c to the positive 8 like this. Yep.
At the start, could you not flip the C and D?
Yes, there's different ways. There's different steps for that. Absolutely, yeah. So if you wanted to take this negative right here and say, hey, I know what the negative does. It flips things. Then yeah, you would go d squared over c squared, and that's to the positive 4. Yeah, you could do it that way too.
Okay.
Yeah, no problem. And then that's d to the 8 over c to the 8. You get the same answer. Absolutely, for sure. You bet. Good question. All right. Okay, let's do G. Okay, you guys got some practice on your own. So let's do G together here. So this one to the power of negative 4, this applies to each factor. So c cubed is a factor, d squared is a factor. So this is going to be c to the negative 12, 4 times 3, and d to the negative 8. All right, so they both have negative exponents. They both have to go to the denominator. So when there's nothing left in the denominator from when you like move things down, then you put a 1 up there. Okay, so this is 1 over c to the positive 12, d to the positive 8. Okay, so don't leave it blank like this. That doesn't make sense. Can't leave it blank. It has to be a 1 there. Okay. Let's do one more. Let's do h here. So h, you can do this again different ways. You could apply the exponent first, or you could apply the negative exponent inside first. So I'll do that. I'll write this as x over y. X over y cubed. You see, this negative 1 takes the y down to the bottom, and it's a positive 1 exponent, right? But we don't write the 1 exponent. And so this would be x cubed over y cubed. No brackets, no negative exponent, done. All right, so tell me if you're good with that. Good with that or not good with that? Good? 5 out of 5? All right. Any questions? Question? No? Okay. All right. All right, then, let's take a look at your assignments on Mr. MathWell.com. You don't want the calculus probably assignment, do you? No. So let's see, your 4.6 assignment. Computer. Hello, computer. 4.6 assignment.
No, we don't have to just text them, we just do the question. Yeah, so then we have to do the question from our book, but the calculus assignment is probably smaller than ours. No, we just do the calculus assignment, like that number of questions in ours.
Okay, so you're doing the PDF version here.
Good idea.
Well, don't let all the letters fool you. I'm just basically telling you don't have to do all of 3. You don't have to do all of 4 or 5 or 6 or 7 or 9. So, yeah.
That's not a good movie.
It's a documentary.